In this lesson, we're going to return to expected value. We're going to have a look at some simple expected value arithmetic. And we're going to revisit example 15 for this. So in example 15, if you remember, it says that a person buys a lucky ticket for $1, 20% chance of winning $2, 5% chance of winning $11, and here is the distribution table. So we've got an overall gain of minus 1.75. That's when they lose. An overall gain of 1 is 0.2, and an overall gain of 10 is 0.05. Remember that we've taken away the $2 that was required, the $1 that was required to buy the ticket. So this is the overall gain. Without going through it again, there was a calculation which worked out that there was negative 5 cents per game. So what would happen if we tripled the outcome? In other words, the overall gain was minus 3, so you're losing $2, I suppose, or 3 or 30. What would that do to the expected value? Let's have a look at it and see what happens. You might want to pause the video and think about it yourself. All right, here's the table, and you can see I've got what we're doing here. I'll just zoom up on it so you can see it. We've got the expected value that we worked out before, which is 5 cents, negative 0.05, which means we're down 5 cents on average per game. There's our table, and I'm going to add another column in here, and it's going to be, or row, and it's going to be the probability, so it's just going to be 3p. So 3 multiplied by p. Okay, so let's have a look at what happens here. We would have, instead of minus 1, minus 3. Instead of 1, we would have 3. And instead of 10, we would have 30. So the expected value of 3p, we're going to calculate this the usual way by multiplying these together. So we're going to have negative 3 multiplied by 0.75 plus 3 multiplied by 0.2 plus 30 multiplied by 0.05. And I encourage you to pause the video and do the calculation for yourself so that you can get the answer. Okay, if you did that, you would have got a final calculation of minus 0.15. Can you see the link between this and this? I'm hoping you've seen that this value here is 3 lots of negative 0.05. In other words, E of 3p is the same as 3 lots of E of p, which is great, which means that if we scale up our gain row, rather than having to do a recalculation, we can just take the original calculation and apply the same scale to it, and we'll get the new expected value. That's kind of handy. Second example. In this one, I don't know if you can see this or not, but I've subtracted 1 from each of the gains here. Okay, so we've got 0, 2, and 11 to start with. Sorry, quick correction. What I've done is I've not removed that initial cost of the ticket here. So instead of being minus 1, 1, and 10, I've got 0, 2, and 11. Okay, so that means that if I had to take it into account, I would have to subtract 1 from the cost, or from the gain row. So I'm proposing to you that in a similar way, this would be the same as taking E of x. I should be saying E of p, but anyway, I've got it as E of x now, which is that minus 1. In other words, I'm saying that we can take away 1 after we've worked out the expected value. And this is in fact true. Let's have a look. 0 multiplied by 0.75 plus 2 multiplied by 0.2 plus 11 multiplied by 0.05 this will give us an amount of 0.95. But we have to take away the $1 that we paid. So we'll take away $1 here, and that gets us back to 0.05, the amount that we should have lost. So we can see that this sort of calculation works as well. So in summary, if there's a loss to be made, like $1 per game, you can write your probability table out just with the gains, calculate that, and then subtract the amount as well. So when I add or subtract something from here, I can bring that out to the outside like so. Okay, let's put that as a summary here. Summary looks like this. If I have A multiplied by X plus B, the A can go in front of the E like this, so we can scale up the original expected value of X, and plus B can go here. Now, this works effectively because what we're putting into the expected value function is a linear expression, ax plus b. If it's nonlinear, like x squared, it is not true that we can take the operation squared and then just square e of x. It does not work that way. Similarly with square root of x, etc. So it'll work with multiplication, it'll work with addition, it will work with division, because a division is just the same as multiplying by a fraction, and it'll work with a subtraction, because a subtraction is the same as adding a negative number. Okay, but it won't work with squares, square roots, log, whatever you like. It won't work like that. It might, but it probably won't. Okay, so that's the end of this video. I want you to absolutely go to exercise 15D. This is not optional, and do question 7, A and C, just to make sure that you get the idea of what you're doing.